Hi folks, we're going to take a look at one of the classic problems in analytic geometry, and that's finding the distance between a point and a line. So the first thing I'll do is I'll draw a diagram to help guide me through this process. So say I've got some given line, so 2x minus 3y equals negative 21, and I want to find the distance from the point to 9, or to negative 9 to this line. Now, not surprisingly, the way we define the distance between a point on a line is, is the shortest distance. In other words, the distance that you get by joining that point to the line in a perpendicular way. Okay, so let's try to set out a strategy for solving this problem. So in order to find this distance, really what we would need is this point that is on both the given line and on this perpendicular segment. So in other words, what we would need is the point of intersection between these two lines. Now, in order to find that point of intersection, I would need equations for both of these. Now, I already have the equation for this given line, so the first thing I should be aiming to do is to find an equation for this line which contains the segment that I'm looking for. Okay, then once I find that equation, find the point of intersection, and once I have the point of intersection, I can then use my distance formula. Okay, so how are we going to go about finding this equation? Well, if I know this line, I'll know its slope, and then from there I can determine the perpendicular slope for this perpendicular line, and knowing a point on that line to negative 9, I'll be able to find the equation. Okay, so our first step is to find our slope. Okay, then step 2 is to find the equation of the perpendicular line that passes through to negative 9. Okay, then our step 3 is to find the point of intersection. Okay, and we'll do that by solving a system of equations. And then step 4 is find the distance from, let's just fix that here, distance from our point of intersection to negative 9. Okay, so this is the plan. This is what I'm going to try to follow here. So let's go to step 1. And let's find the slope of the given line. So I'll do that by rewriting it in slope-intercept form. So I'll solve for y. Negative 3y is equal to negative 2x minus 21. And divide both sides by negative 3. So here I'm left with 2/3 x and then plus 7. Okay, so the slope of this line is 2/3. Okay, so now what I need to do is find the equation of this perpendicular line. So that'll be step 2. And the first thing I can do is find its slope. So since these two lines are perpendicular, we know the slope of the perpendicular line will just be the negative reciprocal of that original slope. And we know a point on that line, which is 2, negative 9. So if we have a slope and a point, again, I'll use slope-intercept form to find the equation. So y equals mx plus b. So we'll input our x and y values and our slope to solve for b. So negative 9 is equal to negative 3/2 times our x value, 2, plus b. Here, the 2's reduce, so I'm left with negative 9. Bring that negative 3 over, so plus 3 is equal to b. So b is equal to negative 6. Okay, and now we can set up our system of equations to find the point of intersection. So here, step 3, we have our original equation, 2/3 x plus 7. I'll just leave everything in slope-intercept form. And then we've got our perpendicular line, which is negative 3/2 x and plus our y-intercept here, so minus 6. Okay. Now, since the y's are already isolated, I think it makes sense to use substitution here. Okay, so I'll substitute this y value by the expression 2/3 x plus 7. So 2/3 x plus 7 equals negative 3/2 x minus 6. Okay, as I always suggest, I would say multiply both sides in order to get rid of those denominators. So if I multiply both sides by 6, that'll do the trick. So here 6 divided by 3 is 2 times 2, so I'm left with 4x. 6 times 7 is 42. Okay, please remember when you're doing this, you have to multiply the whole side by 6. Same thing with the other side. Okay, so here 6 divided by 2 is 3 times negative 3, so negative 9x, and 6 times negative 6 is negative 36. Okay, so let's group together our variables. So here plus 9, so we're left with 13x on the left, and negative 36 minus 42 is negative 78. And now we can easily solve for x, and that turns out to be negative 6. Okay, now that we have our x value, we can just input into one of the equations to find our y value. So I'll pick this first one here. So y is equal to 2/3 times negative 6 plus 7. So here that reduces to 2. So we have negative 4 plus 7 is equal to 3. Okay, so if you want to check that, if you have time, you can always plug the negative 6 into the other equation. Make sure you get 3. So let's check that out here. Negative 6, okay, reduces with 2, so we're left with negative 3 times negative 3 is positive 9, minus 6 still gives us 3. Okay, so our point of intersection here is x equals negative 6, and let's make sure we got a point of intersection here. So x equals negative 6 and y equals 3. Okay, and now that we have, let's go back to our diagram. Now that we have this point of intersection, the only thing that's left to do is to use the distance formula to find that distance between the point and the line. Okay, so here we've got our point, so that's step 4, our point negative 6, 3, and the other point is just 2, negative 9. So let's plug that into the distance formula. So here we've got the square root of negative 6 minus 2 squared. Okay, and then plus here we've got 3 minus negative 9 squared. Okay, so that gives us negative 8 squared is 64, plus 3 plus 9 is 12, so 12 squared is 144. And so our final answer here will be 144 plus 64 is 208. So the distance between that point and the given line is square root of 208 units. Okay, so now try one of these on your own. There's one on that Analytic Geometry 2 sheet that you've got. Okay, have fun.